All right, I think we're recording
Excellent.
now, so we're good to go.
Yeah, I'm gonna share my screen and I can start. So good afternoon, good evening, everybody. I guess it's more the evening for you. I'm Stéphane Lacrampe. Very nice to meet you, and thank you very much, Jeffrey, for inviting me for this session. Um, I'm one of the founder of Obeo. This is a company I founded in 2005, managed the company for 12 years, and I moved to North America in 2018. I'm based out on Vancouver Island, so west coast of Canada. It's 3 p.m. on my side, so still in the middle of the afternoon. And yeah, today I want to talk about Arcadia and Capella, and the idea of this kind of tutorial demo session is to introduce you with the Arcadia methodology and with the Capella tool with some times on the demo with the tool. Feel free to interrupt me if you have any questions. I will try to monitor the chat. I'm going to try to pop up the chat there, but also feel free to unmute yourself and ask any questions while I'll be presenting. So I want to start with a few words about Obeo, my company. So we are a mid-size software vendor. We are about 70 people in the organization. We are headquartered in France. I'm in charge of the subsidiary in Canada and managing the operations for North and South America. I'm also in charge of a team of business development on the Asia-Oceania region. And at Obeo, we are a software vendor with, I would say, two main characteristics. The first one is we are specialized in developing modeling tools and modeling softwares. We've been doing that for the last 20 years. And the other characteristic of the company is that we do a lot of what we do in the open source. We are active in three main domains of activity. The first one is what we call domain-specific modeling with an open source technology called Sirius. We are basically helping customers to develop their own specific modeling environment when they want to use models to manage complexity in fields where there are no standardized tool to manage these domains. The other field where we are pretty well known and active is MBSE. I'll be talking about the Capella tool today. And we have also another pretty well-known tool called CSON, where we are implementing the CSMLv2 standard. I will be mentioning that at the end of the presentation. And finally, we also have a significant part of our activity in the enterprise architecture domain with a tool called Obeo Smart EA, where this tool is implementing the Archimate and the BPMN standards. All right, next slide. Right, so the company is headquartered in France. Most of our technical teams are based in France, but we do have presence in North America, mostly in Canada, in Brazil, as well in South America, in India, and in Australia as well. So, you know, we are a small company, but with a worldwide reach, and beyond those employees that are in different countries for us, we also have a network of partners. This is an overview of the different partners that we have on the MBSE and domain. We have other partners for our other domain of activities. I mentioned the open source aspect of our business. I'm showing on this slide a list of the different technologies that we have contributed to the open source over the years. And all of them are still used by our customers and maintained and are evolving. And obviously, Capella is there. The story with Capella is a little bit different, and I will talk a little bit about that. But Capella was actually developed by Thales, and this is CSON there that we have contributed about 2 years ago. And so some final words about Obeo, because we are doing a lot of open source. People often ask, how do we make money? We are making money in 3 different ways. The first one is around professional services, and those professional services are focused on the fact that we are a tooling company. So we are not a systems engineering company. And that's why we have this network of partners that can help our customers use the tools and the technologies that we developed, help them to use them in their context. So we rely on them for that type of services. The services we provide are more towards the tooling itself. So basically, when you need to customize and extend the tools, when you need to integrate them with other tools, or some organizations are working with us to help us to improve the features that are available directly in the open source tool as well. Now, beyond those open source tools and professional services that we provide, we also have some commercial add-ons that we sell, so some commercial license. And those add-ons are going to be extending some of the features that are available in the open source. And those features are generally becoming very useful when used in large, complex environments and large operational industrial projects. So typically, some features around authentication, team management, team collaboration. These type of features, we generally commercialize them as commercial add-ons. And finally, we are also getting some revenue out of some SaaS activities that we have. So meaning that we are able to deploy some of these tools in cloud environments, and some of our customers are relying on those services that we operate in the cloud to use those tools, whether they are MBSE or enterprise architecture tools. And the final thing that I wanted to say is that although we are a small company, we are very much used to work with very large organizations, and more than 90% of our customers are large organizations. All right, so let's dig in today's topic, which is Capella. So what is Capella? Well, it's basically an MBSE tool. It's a pretty mature MBSE tool, and it comes with a method. I will be talking quite a bit about it. And the goal of this tool is to help system engineers to design good system architectures. So the scope of Capella is very focused, and it's a very well deployed tool as well that has been used successfully in a lot of different domains where systems engineering is used, basically. So what are the main objectives when using Capella? First of all, Capella is used to better understand the customer need. And you will see that when I will talk about the Acadia methodology, there is quite a significant place in the methodology for modeling and understanding the need. It's also used to define and share the solution among the different stakeholders, meaning, that Capella is a system architecture tool, so it helps you to define and design the system architecture of the solution and to share this information among the different stakeholders of the project. It's also used quite a bit to secure the downstream engineering activities and subcontracting, and I will talk a little bit about that as well. I've heard a noise on my laptop, so I'm wondering if someone posted something in the chat. No, so I don't know what it was. But anyway, sorry about that. It's also used to early evaluate and justify architectural design. And finally, it's also used to prepare and master the verification and validation activities. Because the way the data model is organized in Capella and in the Arcadia methodology through one of the very important concept is functional chain. This functional chain proved to be very useful for managing the verification and validation activities. So just a little bit of history about Capella. So back in 2007, Thales called us and they had developed this Arcadia methodology that is basically, how you're going to be using those models and doing those models in the context of Thales to improve their systems engineering capabilities. And based on this methodology, they needed a tool to support it. So they initially tried to implement this Arcadia methodology using the SysML tools that were available at that time. But for some different reasons, that was not successful. And there have been some papers published on why it's very difficult to support the Arcadia methodology with SysML v1, which is not the case with SysML v2, by the way. But anyway, they decided to build their own tool, their own modeling tool to support this Arcadia methodology. And for that, they called us, Obeo, and we helped them to develop this tool. The first deployment of the tool happened at the end of 2009. And after a couple of years, it became quite a success within Thales. They have done more than 500 successful projects since then with Capella, so it's quite a successful deployment on their end. But they decided to open source the tool in 2014. So this happened at the end of 2014. So Capella has been open source since 2015, roughly. And this has obviously created some interesting opportunities for us at Obeo. And we've been, advocating on Capella since then. So the scope of Arcadia and Capella is mostly system architectural design and software, hardware, and architectural design as well. You can do a little bit of enterprise architecting. You can do a little bit of VNV. You can do a little bit of non-functional analysis as well. But really, the core of Arcadia and Capella is system architecture and subsystem architecture. So, by the way, I don't think I have a specific slide on this topic, but Arcadia and Capella are not. Capella is not a SysML tool. It's not a SysML v1 tool. It's close to SysML. A lot of the concepts that are in Capella are inspired by UML and SysML. But it's not a SysML tool, and the reason why I'm saying this is because I was talking of the scope, and the scope of Capella is not as large as SysML is. It's really focused on making sure you're going to be able to design good system architectures. It's really focused on the system architecture topic. And the way you can view Capella compared to SysML tool is a SysML tool that would have been already profiled specifically to support the Arcadia method. So the concepts that you're going to find in Capella are not concepts like parts and actions, but concepts like components and functions that comes from the Arcadia methodology. So a little bit like if you have a component profile on top of a part, if you were thinking about SysML v1. So the important point here is that there are two things when we are talking about Capella. First, there is the Arcadia methodology, which is very central to the Capella tool because Capella implements the Arcadia methodology. And the way you can view Arcadia is kind of a modeling framework that is going to help you structure your models and your modeling activities. And Capella is dedicated to supporting this modeling framework and helping the users to execute those activities. So this means that if you want to use a completely different methodology, Capella is probably not going to be the right fit for you. But on the other side, Arcadia is a pretty generic and general technology methodology. It's very close and very aligned with the 15 to 88, especially the first 4 technical processes. So you can apply it in a lot of different contexts, domains, and system engineering processes. The bottom line being that in a lot of cases, the methodology maps very well with the system engineering processes that are developed and deployed in large organizations. And finally, what I want to say on this introduction is that one of the reasons why Thales developed this Arcadia methodology and this Capella tool is that when they started to experiment MBSE in 2005, so very early stage of MBSE, they had some very promising results, but they struggled with having the system engineers to use the system tools at that time and to have the stakeholders to also use that type of language. So one of the big ideas behind Arcadia and Capella is to bring in a pragmatic way of doing MBSE and a pragmatic way of doing those architecture models so that those models, those artifacts, this data can be shared and used among the different stakeholders that are involved in a large systems engineering project. All right, now I would like to focus on the Arcadia methodology. And one of the reasons I'm focusing on the Arcadia methodology right now is that I'm going to be switching to a Capella demo after that. And it's important that you have some knowledge on the Arcadia methodology to better understand how the Capella tool works. So these slides represents what we call the Arcadia datasheet. This is a 4-page document that gives you an overview of the methodology. And the methodology is broken down into 5 engineering perspectives. And the 2 first engineering perspectives are about modeling the need. And the 3 next engineering perspectives are about modeling the solution. And I'm going to enter a little bit in details about those engineering perspectives, focusing on the first 4 engineering perspectives because these are the most used one. But the most important thing you want to remember about the Arcadia methodology is that it's going to drive you, meaning it's going to drive the user of the Capella tool to adopt certain perspectives. And the goal of adopting those perspectives is to make sure that the architecture that you are developing is complete and is consistent for the system that you are going to develop. And so the first perspective is called the operational analysis. And in this perspective, the model that you're going to build is going to try to answer the question what the stakeholders need to accomplish. So what I mean by that is that in this perspective, you are building kind of a separate autonomous part of your model that is really dedicated in answering this question about what the stakeholders are trying to do. And in this perspective, you are not going to be modeling the system of interest at all because you are trying not to make any assumption about the boundaries of your system to make sure that you can provide the best solution to the problem that you have. And I believe that this first step is not often managed in system tools But I think it's a pretty important question when you are transitioning to the system analysis and the solution of your system, meaning that, asking the question why are we doing these systems? What are the stakeholders are trying to do? Are some very important questions to ask yourself with regards to the fact that we generally engineers, believe that we know what the customers want, we know how we operate and design the systems, and not asking those questions. Sometimes we are missing some very important innovation opportunities, for example. The next engineering perspective is the system need analysis. And there we are going to build a model that is going to answer a slightly different question. The question is what the system has to accomplish for the stakeholders. So at this stage, we are modeling the system itself, but as a black box. And we are trying to identify what is the boundaries, what are the boundaries of the systems, what functions are going to be the responsibility of the systems, and what functions or activities are going to stay outside of the systems and performed by the different stakeholders. And so those two first engineering perspectives, the operational analysis and the system need analysis, they are very often used in conjunction and as a support for discussion with the stakeholders and the customers. So really focused on modeling the need. The next engineering perspective is called the conceptual architecture, or we call it also the logical architecture. And so here we are not modeling the need anymore. We are modeling, so building a model that is going to answer the question how the system will work to fulfill the need, to fulfill the expectations. So we are modeling the system of interest as a white box now, but we are trying to model this system without making any assumption on the technical choices that we're going to make in the next steps. And the interest and the goal of this logical architecture layer is to identify some reusability, especially when you're going to be in the context of product lines. And finally, when you are in the finalized architecture, we call it the physical architecture as well. We are going to build this model that is going to answer the question how the system will be developed and built. And so this schema on the left, show you a visual representation of the structure of the Capella models that you're going to build. And you're going to see in the demo that this is really how those Capella models are structured. And you see that we have red red lines here, red relationships between those layers, meaning that between each engineering perspective, there is relationships that explains that, let's say, this physical component in the logical architecture is here because of this system function expressed at the system analysis, and is here because of this stakeholder needs and activity that we have modeled at the operational analysis level. So there is really you are really building the traceability from the stakeholder need down to the system architecture with the Arcadia methodology. And also requirements are still here, meaning, textual requirements. We although Capella is a modeling tool and a system architecture tool, we reckon that textual requirements are still key artifacts of our systems engineering practice. And so embedded within the method, there is a way, to manage and link your requirements with your models. This approach has been described in a paper that was published in the IS 2019, and that was awarded the best MBSE award at that time. So if you are interested in this, I would say, general topic of how to manage textual requirements with system architecture models, it's a very interesting paper there. All right, so I already mentioned that Arcadia is very closely aligned with the IEEE 15288. And now I want to talk a little bit about some of the Arcadia main concepts that are going to be useful as well for you to understand the demo. And also because you're going to see that we don't have that many concepts in the Arcadia methodology. They are pretty simple, pretty standard for system engineers. So it's actually pretty easy to catch up with the Arcadia methodology. And so the main concept that we have starts with capability, and capability is a high-level, let's say, function that is or service that is performed by the system to accomplish a mission. And capabilities are described either by functional chains or scenarios, or both, basically. And those functional chains or scenarios, what are they? They are basically a set of functions and functional exchanges. We also have concepts in the Arcadia method for components and actors, and component exchanges between those actors and components. And functions and functional exchanges are allocated to component and component exchanges. We also have concepts to manage interfaces and also concepts to manage modern states. And with that, you have, first a very good understanding of what you need to know when you're going to be using the Arcadia methodology. And those concepts, capabilities, functions, and components, they are reused systematically across all the engineering perspectives. So typically, if I take functions at the operational analysis level, well, we don't have operational functions. We call them operational activities, but they are pretty much the same concept. And the reason why we call them operational activities is that the concepts that we manipulate at the operational analysis level, they are coming a little bit more from DODAF and this type of architecture frameworks than SysML. But they are pretty much equivalent to what we call then system functions for the system analysis. And then we have logical functions for the logical analysis layer and physical functions for the physical layer. And the same relationships where we have operational capabilities are described by functional chains or scenarios. They involve operational activities, which are kind of functions, and they are allocated to components and actors. And that's the same in each layer of the methodology. So that means that once you have understood what they mean and how they work together, you're going to be able to use them in all the different layers. Simply, you are not asking yourself exactly the same question, so you are not modeling exactly the same thing. And this is what is going to drive you, how you use those concepts to build those perspectives models. All right. So before I switch to the demo, what I want to say is that the way I introduced the Arcadia methodology is a very top-down approach. And the way I'm going to do the demo with Capella is going to be also a very top-down approach because it's easier to understand and to learn that way. But both the methodology and the tools support different type of approaches like bottom-up or iterative incremental approaches. All this way of using the methodology exists. And when we are looking at what customers are doing with Capella, well, in more than 50% of the time, they are not starting with a blank page and a new system, but they have an existing system that they want to evolve, modernize, or integrate with other systems. And we have a lot of support from a methodological, but also from a tooling standpoint to perform these activities with Capella and Arcadia. All right, let's talk about the Capella workbench now. And before I switch to the demo, what I wanted to say is that what I'm going to be demoing today is made with Capella directly from the open source implementation and from the website. And so if you want to, well, not do what I'm going to be doing, but if you want to experiment and try and reproduce some of what I do, all you have to do is go to the Capella website. It's the URL is mbse-capella.org. You can click on the download button there and choose the version that is right for you. This is a Windows version, and we have other platforms that we support. And yeah, once you have downloaded Capella, all you have to do to install Capella is to unzip the file and launch Capella. That's it. There is an extra step for Mac users where it basically needs to tell the Mac system that it's not a dangerous application, but that's it. All right. So Capella is a quite comprehensive and powerful workbench, and it's there's a lot to cover if we want to support all the features and the capabilities of the workbench. So I'm going to be showing some of it during the demo, but we have a lot of tooling around complexity management, productivity with the models, replicable element and libraries. I will be talking about that a little bit as well in one of our slides, and a lot of add-ons in the Capella ecosystem that extend the Capella capabilities. The bottom line is that what we are trying to do with Capella is to make those modeling activities as simple as possible, to make those model concepts as pragmatic and simple as possible as well, or I would say as close as possible as the concepts that system engineers use, so that system engineers can actually concentrate on solving systems engineering challenges rather than struggling with maintaining complicated models. All right, let me switch to the demo now. And I have Capella there. So when you launch Capella, this is the first screen you're going to see. There are a few menus there, like importing an existing project. That's what we're going to be doing, but I'm going to be showing you how to do it in general, so you can close this window. And there I'm going to be right-clicking and choose the same import menu. And I'm going to import an existing project into the Capella workspace. And when you unzip Capella, there is a samples folder, and it comes with this in-flight entertainment system model that is provided with the tool as an example. So in-flight entertainment system, being the screens and the VOD that you can use when you are traveling on a plane. By the way, if you want to create an empty project in Capella, it's also very simple. You just do new Capella project, and then you give it a name, let's say my project. All right, and it's actually creating the project. It has also opened the project, and the first screen that you see when you create or open a project in Capella is what we call the methodological browser. And here you see the different engineering perspective from the Arcadia methodology. So I'll be diving a little bit into that just after this. What I wanted to show you as well is that if I extend a little bit my project structure, well, you're going to see that my Capella model is already structured by engineering perspective. So I've got the operational analysis, the system analysis, the logical architecture, the physical architecture. These are the kind of the top level package. And then if I expand those package, I can see that I have a package for system functions here. I have a package for logical functions. I have a package for capabilities, structure, which is going to contain our actors and components. So, all this structure is already there for you, because this is very, aligned with how you would structure a model using the Arcadia methodology. Okay, let's delete this project and let's go back to my in-flight entertainment system. So I'm going to open my project. All right, so same methodological browser here. So you can see the different engineering perspectives and some explanation about what they do. It's obviously a summary of what the methodology does. If you're interested to learn more about the Arcadia methodology, I just wanted to show you that on the website, we have an entry for the Arcadia method. This page, gives you an overview of the methodology itself. You've got this document that I showed you in one of the slides. There is a couple of books, but this one, which is a reference book for the methodology, and some very interesting videos out there that describes a model example for each engineering perspective. And these examples are the examples that are available in the Capella book. But beyond that, we have a set of reference documents. So these documents, PDF documents here that you can download, they are all free available and give you some explanation, very detailed explanation of the Arcadia methodology. And this gives you an overview of what these different PDF documents cover with regard to the Arcadia methodology. So very useful resource when you want to deep dive into the Arcadia methodology. All right, so I can click on my operational analysis, and there I'm going to see the different steps and sub-steps that I can accomplish at the operational analysis layer, where I'm going to be defining the stakeholder needs. So basically, you're going to be starting by defining operational entities and capabilities. Again, I'm showing you a top-down approach, but this is not the only way to use the Arcadia methodology. You've got some description here that helps you to understand a little bit what you are supposed to do. So you're going to be identifying the operational domain. So questions like who are the actors and entities, which are their purposes, and the activities of this entity gives a global view upon the operational business goals. And I've got a small icon there with two arrows, which I can click. And what it's going to do, it's going to show you the elements in my model that refers to this step of the methodology. And so typically, if I extend this step, I can see that I can create an operational entity breakdown diagram, and I can create a new operational capability diagram. But because this is an example model, we already have some diagrams that show that. So I'm going to be, for example, opening these operational entities and actors. So these are the entities and actors that have been identified for our system. We've got the crew, the aircraft, the airline company, the personal device, ground operator, the passengers, etc. And more interestingly, we're going to be looking at this operational capabilities diagram. So maybe, yeah. So we have 3 operational capabilities that have been identified. First one is entertain during flights. The second one is perform flight onboard announcement. And the third one is implement a commercial strategy. And we can see the relationships between those operational capabilities and the different entities and actors that are involved with these capabilities. Before I go a little bit deeper in the model, I just want to say a few words about the environment. So what you've got here on the left of the screen is the Project Explorer. The Project Explorer gives you a hierarchical view of your model. You can also browse the different representations, so meaning diagrams or tables that are available. For example, here for my operational analysis, I can see that I've got an entity scenario, I've got an operational activity breakdown, etc. So I can navigate those diagrams, which are all sorted out automatically for you there. We have an outline of our view there, and our main view, diagram view is at the center and left of the screen. We've got the tool palette where we can create elements here. And finally, at the bottom center and right, we've got some other views like the property view and the semantic browser that I will be talking a little bit about later. Right, so if I look at this entertain during flight capability, I can see that there is a small icon there, and this icon means that there is actually another diagram that is attached to this operational capability. So I can navigate this diagram, right? It's an existing entity scenario called flight phases. So I'm going to be navigating to this scenario. And while I do that, I just want to go back to this slide just to remind you that what we are looking at is capabilities, actually operational capabilities. We are looking at some actors as well, like the airline, the passengers, etc. And I just navigated to a scenario, and the scenario is something that is describing a capability, and that is going to involve some function and functional exchanges. So the scenario here describes that the aircraft, while being on the boarding state, the cabin crew is going to request to play some ambience music, and the passengers are going to listen to the ambience music. And we could be displaying the actual activities there. It's not done on this diagram, but that is typically something that we could do right there. Just to show you, listen to audio. All right. So typically in those scenario, we would display the actual activity that is performed by the entity on the line. And then during takeoff, the cabin crew is going to request to play some safety instructions, and the passengers are going to be watching an INCOSE movie and so on. You know, while in the cruising mode, some things are going to be happening with regards to what our stakeholders are doing in terms of activities. So going back to my operational capability diagram, you may have spotted that right now on the diagram, we are just showing the passenger and the cabin crew. And we are not showing the aircraft, which is actually involved in performing this capability, as we just saw in the previous diagram. One of the reasons is because those diagrams, they are not necessarily synchronized with the model, because the users are going to be creating multiple versions of these diagrams, and they may want to put different elements in this diagram, like in a blackboard, they're going to put things or remove things. But if I look at the semantic browser, I'm going to be able to see that as well. So the semantic browser is an interesting view in Capella. It gives you contextual information with regards to the element that you have selected, and this contextual information is generally interesting with respect to the Arcadia methodology. But what I can see is that this element, operational capability, is represented in two different diagrams, the scenario diagram and the operational capacity diagram, that is the one that we are just looking right now. And we can see here that there are three involved entities here. So I can actually drag and drop the aircraft on the diagram, and then now we see that the relationship actually exists in the model. But simply, we were not displaying the element and the relationship in this specific diagram. It may be something that we have forgotten to do because this element was created afterwards. We created this diagram, or it may be something that was done again for purpose because the user decided that there was too many elements to be displayed. Right. What I can maybe show you now is I can now remove again this element from the diagram. There are a few ways I can do that. For example, I can do an undo, so hit the Control and Z, Control plus Z button, and it's going to undo what I just did. So I'm going to redo it. Okay, Control plus Y. The other way I can do that is I can decide to remove this element from the diagram manually. So in the toolbar that I've got at the top of this diagram, this is one of the things I can do. I can delete it from the diagram. So if I do it, the element is not in the diagram anymore, but it's still in the model and it's still in relationship with my operational capability. Like if I bring it again on the diagram, it's going to be displayed there. So I'm just trying to show you the difference between the diagrams, which are views on the data that we have, and the actual data, the actual semantic data that is in the model. If I want to actually delete this aircraft element, I'm going to have to hit this double cross icon. It's going to delete it from the model. And if I do that, I've got a pop-up that is showing me all the impact of this deletion. And obviously, deleting the entity aircraft is going to have a lot of consequences on my model because it's an element that is used not only as a relationship with the capability, but in a lot of other contexts, like the scenario that we just saw. It's linked to the modern states because we have models the modern states of the plane, etc., etc. So I'm not going to do that actually. All right. So next, we can look a little bit more in detail of some of the next steps. So the next step in the methodology is to define operational activities and describe interaction. So I'm going to synchronize with what diagrams are available in my model. And I'm going to open, let's see what I want to do. I can look at all the activities. So this is, an overview of all the activities that we have defined at the operational analysis level. They play the same role as functions, right? Actually, I'm going to be diving a little bit more into the functional analysis in the next engineering perspective. So what I want to do now is move to the next step, which is the allocation of activities to operational actors, entities, and roles. This is a very important step in the Arcadia methodology. This is where you're going to be, first thing you do is define the entities and the actors. And in the next engineering perspective, you're going to be defining the components of your systems as well when you're in the solution side. Then you do the functional analysis, so you define your functions, and then you allocate your functions to your components so that you are able to say, okay, this component or this actor is going to be responsible for performing this activity or this function. And this leads you to the creation of operational architecture diagrams or architecture diagrams in general, which are very important diagrams in the Arcadia methodology. So if I open this diagram for the operational analysis, this is our operational analysis for our in-flight entertainment system. So we can see that we have passengers. The passengers is going to perform a certain number of activities like listen to audio, watch movie, watch moving map, etc. The aircraft is going to be responsible for different activities as well, like broadcasting movies, broadcasting audio. The crew is going to do a certain amount of things as well. make priority audio announcements, set flying mode, etc. And we have, personal device, ground operators, etc. And we have, activity exchange between those activities as well. Now, what I want to talk about is this blue line that we see here. And this blue line is the representation and the materialization of a functional chain. Okay, so again, back to this slide. Now we are looking at a functional chain that describes the capability and that involves some function and functional exchanges. So this functional chain is called perform audio announcement. And you see that to perform this chain, what's going to happen is that the cabin crew is going to make an audio announcement. The aircraft is going to broadcast the audio, and the passenger is going to listen to the audio. And we're going to see later in the demo how those functional chains are later used. But this is a very powerful concept in the way Arcadia work, in the sense that this methodology is really capability driven, and you are able to explain those capabilities by showing the different paths between the functional flow, so between the different functions that you have in your systems. One additional thing I would like to say is that you see that in this operational activity, in this operational analysis perspective, in the Arcadia methodology, we are not modeling the in-flight autonomous system. We don't know exactly where it's going to be and what role the system of interest is going to have. We don't want to make any assumption yet about what it's going to do. What we want to make sure is we understand the context. We want to make sure we understand the business of the different stakeholders and the goals of the different stakeholders before we define where the system is and what role it's going to play. All right, last step that we've got here in the methodology is called transverse modeling. You're going to be finding those steps in all engineering perspectives. And what you're going to be finding there is the ability to model modern states and also to model data. So this is called a class diagram, but basically it's used to model data, meaning data that is going to be flowing between those different activities. And I'll be talking a little bit about that later on. I can actually synchronize and just go quickly to an example of an activity diagram that is the aircraft flying phase that we have modeled there in terms of states. All right, I just wanted to quickly go back to the presentation. What we've seen right now is the first perspective in the Arcadia methodology, which is the operational analysis level. So what we are trying to make is to develop a model that is answering the question of what the users, stakeholders need to accomplish. We are not modeling the need. This is, just another example for a radio where we are explaining the context of where a radio would operate, but not modeling the radio itself right now. All right, so we're going to be moving to the system need analysis. And there in the system need analysis, what we are going to model is what is expected from the system. So we're going to be modeling the system as a black box. So here in our example, this is our radio set. This is a black box. We are not going to be explaining how the radio set works. What we're going to be modeling is what the radio set is supposed to do. So it's supposed to enable to play radio contents. It's supposed to enable you to select a radio station, etc. And so defining the boundaries and the interfaces between our systems and the external actors. All right, so let's move to the system analysis. And the first thing that we're going to do, that we can do here, is to perform a transition. So to help the users, what you can do is you can actually transition some information from the operational analysis, right there, from the operational analysis down to the system need analysis. I'm not going to do it because this has already been done, but this is really useful the first time you do the model. Now, when you are evolving the model, because this is a very iterative process, you can do those transitions on the elements that you are creating. So let's say typically that I'm going to add an operational capability. And what I want to do with this capability now is I want to transition it to the system analysis layer. Okay, I'm going to apply the transition. And if I go now to my system analysis and to my capabilities folder, I can see now that I have an operational capability 4, right? If I go back there, which is exactly the same name here. Okay, so it has transitioned my capability. If I look at the semantic browser on my operational capability 4, I can see that it is realizing an operational capability that is the same operational capability 4 that I created. So going back to my slides here, what we are looking at is this red realization link between an operational capability and a system capability that I just transitioned. Okay, so now obviously now that you have transitioned this operational capability, the question you're going to be asking yourself is, how is this operational capability going to be realized at the system analysis layer? Meaning, what is the system going to do to realize this operational capability? So this transition is just an initialization. It's not just for the sake of copying and pasting object from one layer to another layer, but more to initialize your thinking and say, okay, now I've got these operational capabilities that I've created at the operational analysis layer. What am I going to do if I want to realize it at the system analysis layer? So let's open, for example, the mission and capabilities diagram. Okay, so we don't have operational capabilities anymore. We have system capabilities. But we see that we have many more system capabilities that we had operational capabilities, because when realizing those operational capabilities, we are defining several system capabilities to achieve those operational capabilities. And so if I was to bring in this operational capability in this diagram, I would probably start by renaming it and say, okay, now to realize it, I'm going to have my system capability. Obviously, this is not how you name a capability, right? It's things like provide audio and video intercommunication means. But just for the sake of the example, and then you may even say that this operational capability may be actually realized by several system capabilities, which is what we did here. Right. So we see, the same type of diagrams. We have capabilities. We have an additional concept here, which is mission. This is a particularity of the system analysis, where we have this concept for mission. If I go back to this slide here, we see that we have an exception here with the concept of system mission. So this is what we are seeing here, and we see that capabilities are linked to entities and actors. And again, I have a sub-diagram. I can navigate to scenarios or functional chains. Right. So what I want to focus a little bit more on at the system analysis level is the functional analysis. So this is something that Capella is pretty strong at, is to support functional analysis in terms of modeling, and that's something that is not always easy to do with SysML. So what we are able to develop with Capella and Arcadia in terms of functional analysis is a hierarchy of functions. So typically, I can open this hierarchy of function, and these are all the functions that we have defined on our system of interests. We have other functions as well. Sorry, I'm going to close this diagram. I wanted to go there. We have other functions as well, which are the functions that are allocated to the actors. And this is a separate tree of functions. So one thing that I want to say about functions in Arcadia and Capella is that in a finalized model and in a finalized functional analysis, only leaf functions are allocated to components. And exchanges between functions happen only between leaf functions. What this means is that the upper functions, like manage passenger service lifecycle, run services, run video on demand, these are actually grouping functions. This is not functions that really exist in reality. They are just a way for logically grouping those functions. And why this is important is because when we are doing functional analysis, this is part of our work as architects, and doing a proper functional architecture is an essential task when doing system architecture, and this is very well supported in Arcadia. Furthermore, you have other means to represent these functions and the interactions between those functions. And typically, I can, for example, open what we call a data flow diagram. And here, what I'm showing is a top-level function. It is a diagram called top-level functional overview, and I'm showing the interactions between our top function and the other, sorry, top system functions, the top function that is allocated to our system of interest, and the top functions that are allocated to our actors. And I just told you that in Arcadia and Capella, in a finalized model, there are no functional exchanges between the grouping functions. The functional exchanges happen only with the leaf functions. But in this diagram, we are seeing those exchanges. And the reason why is because what Capella does is that it's able to calculate all the interactions between the high-level functions based on the actual interactions between the leaf-level functions. So you can build very easily with Capella these high-level diagrams that help you to understand the high-level architecture of your systems without having to maintain those links between those grouping and high-level functions. And you can imagine that when you have a real system with hundreds and often thousands of functions and sub-functions and sub-sub-functions, if you have to maintain those links at every layer, it becomes very impossible to manage, and you don't want to change anything in your model anymore. But that's not the case with Capella, because you only have to maintain the actual exchange that exists between the leaf level functions, which are real functions, and all the other higher level functions. Those links are calculated for you. All right, let's have a look now at our architecture diagram at the system analysis level. So I've got an let's say high-level system overview. I can open this one, for example. So again, this is an architecture diagram, very important diagram in Capella, where we can see our components. So this is our in-flight entertainment system as a black box. We don't know how it's going to deliver its functions. We've got our external actors, the aircraft, the passenger, the cabin crew, and we've got the different functions in green that are allocated to these different components. So functional content in Capella and functions are always in green. And so what I mean when I say that at the system analysis, in the system analysis perspective, you are defining the boundaries of your system is, for example, the fact that we have allocated the play sound in cabin to the aircraft. Well, this is a very, important information that the customer may have given you because we are still, at the phase where we are modeling the need, that the aircraft is still going to be responsible for playing that sound in the cabin. And why this is important is because obviously in emergency situations, you want to be able to make sure that those capabilities are working in the airplane so that you can communicate with the passengers. And so the in-flight entertainment system that you're going to develop and build, and starting with putting a price on it, it's not going to be the same if you have to play to ensure that you are able to play sound in the cabin in those emergency situations. It's not the same criticality and safety level for this system. So typically, I could take this function and move it in my system, and there it has a total different meaning in terms of criticality for our system. And by the way, changing the allocation from of a function from one component to another is as simple as dragging and dropping the function. And Capella is maintaining all the relationships for you when you do that. All right, let's move to the logical analysis layer. I'm going to go back quickly to the presentation. So we were looking at the system need analysis. Now we are moving out from modeling the needs and moving in modeling the solution by starting on the logical architecture, which we call also the conceptual architecture. So here we're going to build a different model again. And the model that we're going to build is going to represent how the system will work to fulfill the expectations. So our radio set is going to have a user interface, it's going to have a radio control, it's going to have a radio receiver. So we are trying to make a logical architecture of our components and refinement of our functions to each system components. But what we are trying to avoid is to make any technological choice and detailed interface modeling at this stage. We want to make this level of architecture as reusable as possible. So let's move to the logical architecture. We could do the transition again, and I'm going to switch directly to those architecture diagrams. And the first that I want to open is, I'm not seeing it here. Templates, what am I missing? It should be, so I haven't clicked operating system, all components, template, broadcast. I'm missing a diagram. That is strange. Oh no, sorry, I'm at the wrong step. So first, the diagram that I want to show you is the breakdown of our system components. So this diagram is called a logical component breakdown diagram, is representing our component breakdown structure. And we have named this diagram architecture drivers because it's explaining our rationale when developing the architecture for our in-flight entertainment system. And so our first architecture driver is going to be that we want to take into account the topology of the aircraft, right? The in-flight entertainment system is going to be on board our aircraft, and so we have a strong architectural constraint that we have to match with the architecture of the aircraft. I mean, the topology of the aircraft itself. So typically, we're going to have some aircraft front servers because this is where the servers are stored in an aircraft. We're going to have some cabin terminals, some cabin screens, and some seat TVs as well. So this is our first level of component decomposition. Our second architecture driver is going to be that we want to group the functions together so as to reduce the interfaces and in order to reduce obviously the cables, but also the performance of the system. And the fact that we did a functional architecture and that we grouped the function together that makes sense to be grouped together is really a big help when we are developing the architecture in terms of component breakdown. So typically, we're going to have an aircraft interface, an application server, a streaming server, a media server, some cabinal terminal interaction manager, etc. And finally, our third architecture driver is that when you are a company and you are building an in-flight entertainment system, you are going to be selling it to multiple airlines, and airlines want to differentiate themselves commercially by providing special features, special capabilities, or special graphical user interface for their in-flight entertainment system. And so that is also something that we are taking into account when doing our functional breakdown. And so typically, we're going to have an aircraft interface, a generic one, and a core one, and then an aircraft specific or an airline specific interface there. Same for the cabin terminal interaction manager. We have a core one, and we have an airline specific one that is going to manage the additional airline specific development and functions that they need. So that is our component breakdown. And now we can switch to our logical architecture diagrams. So I'm going to click there again. Oh, it's not there, the wrong one. I'm going to open. So I have multiple architecture diagrams there, and it's very common. The reason why is, we are doing SE and MBSE because those systems are complex, and it's not like the architecture of the system is going to be made of 10 components. When we see what our customers are doing with Capella, they have hundreds, sometimes thousands of components in their systems, and it's obviously not efficient at all to represent all of them in one single diagram. So we tend to build a contextual diagram, and there are different strategies for that. But one strategy is to represent the architecture with a focus on each functional chain. So this one is the start playing VOD movie functional chain that was created in one of the upper layer, and that has been brought down to this logical architecture perspective by initializing the transition. And we can see that now we have a detailed view of what this means when the user wants to start playing a VOD movie and all the functions and components that are going to be involved in achieving parts of a capability related to playing a VOD movie. Yeah, so what this functional chain is representing is actually the data flow between the different functions, because in Capella and Arcadia, the functional exchanges between functions are representing data flow and not the control flow. And if you want to represent the control flow between those functions, there are ways that you can add some sequencing information in a functional chain. But another very efficient way to do it is actually to represent it in a scenario. So if I go back to my Capella data model, we are still at capabilities are described by functional chain. So we are looking at a functional chain which involves functions and functional exchanges, but they are also represented as scenarios. Scenarios are like sequence diagrams. So you see that they are generally well suited for explaining the sequencing of information. So basically the control flow between functions. And in Capella, we have a lot of engineering helpers. I mentioned that in my previous slide. And one of them, for example, is that you can initialize a scenario diagram based on this functional chain and this functional flow by basically using the functional chain to functional scenario initialization. So this is what I just did. I'm going to navigate to this functional chain in my Project Explorer, and I can see that I just created this scenario here. Sorry, I can do it again if you want. Transition, functional chain to scenario initialization. And there you go. It just created a new scenario here. And if I want to visualize it, I just have to initialize the diagram. And there you go. You've got the corresponding sequence diagram where you're going to be able to start and add some control flow and sequencing information in addition to what the tool initialized for you. Sorry. All right. One thing I want to say as well is that in the way we organize our architecture diagrams, what we tend to do is to build a template. So this is an architecture template of our component breakdown and the main functions that are allocated to it. So we are trying to keep the layout of those diagrams consistent. Like if I was, to go back to the system analysis level and open our system architecture diagram, we still have our system in the middle, the aircraft at the top, the cabin crew and the passengers on the right and the left. And now that we are at the logical architecture and that we are modeling how the system will work, so we are modeling our system in the middle, our in-flight entertainment system as a white box. We still have our aircraft and cabin crew and passenger at the same place. So that's for the user and for the system architect, it's easier to understand those diagrams and what's in this model. And so what we have done here is we have built this template. And what you can do is in Capella is you can actually copy the format of the whole diagram. And once you've done that, you can actually pass the layout, the style, and the format of your diagram. Why I'm saying this is that when you are down to building those contextual diagrams, what you want to ensure is some consistency in how those elements are organized so that you can mentally remember that, oh yes, the passenger, this let's say, light blue box is at the left, which is consistent with my main layout here. And the seat TV is our first component there, which is consistent with this template layout here. And you can copy and paste this layout in all the contextual diagrams that you build so that you have very easily some consistent architecture diagrams. And it's really a game changer when it comes to communication with the stakeholders after that. All right, let's go back to our methodological brother and let's move to the physical architecture. So the physical architecture is there. We also call it the finalized architecture. And here we're going to build a model of how the system will be developed and built. So we are still, modeling our components and subcomponents for our radio set, but here we are indicating that we have an analog board, a serial RS232 cable, etc. So really giving some, technical detail and implementation for our architecture. What we are not doing is the detailed design of each system constituent, because Capella is not a low-level design tool. It's really a system architecture tool. But also, in the case of large systems, what you're probably going to be doing is, okay, I've defined these subsystems, and this subsystem is going to be developed by this team in my organization or this supplier. And what you can do with Capella actually is take this subsystem and initialize a new Capella model out of it, where this is going to become the specification of your subsystem, right? This is the interface that you have to respect as a subsystem team, because this is the way that the architecture has been defined at the system level. So Capella support this type of activities as well. All right, so go back to Capella. We are at the physical architecture level. Let's go again to the architecture diagrams. And I want to look at an architecture diagram that is focused on the network transport. So what this diagram is showing is that between the private video display unit, so basically the screen that is on the seat of a passenger, and the video server unit, there is a gigabit Ethernet physical link that goes through the Ethernet switches of the plane. So this is defining the interfaces between those physical components. And what is interesting here is that in Capella, we have a very explicit way to define the interfaces. And I'm going to explain that quickly. So this is in yellow, you have the physical components. This blue line here is the network path, the physical path between those components, and how those interfaces are defined. They are defined against the behavior of the system. So in blue, we have behavior components, and behavior components are going to be responsible for executing functions of our performing the functions of our system. And so here we have functional exchanges. And in these functional exchanges, we are defining the data that flows between those functions. Could be data. In our case, this is data. Could be other things. Could be energy. Could be a fluid, etc. But this is at the functional level that we are defining what flows between our functions and what are the dependencies between our functions. Those functional exchanges, they are allocated to our behavior component exchanges. You see the allocation here with the little dashed lines. And this behavior component exchange is actually allocated again to our network path, which means that the actual data flow that is flowing in our network path, which is representing our interface, is actually defined by the functional content that we have modeled, right? And so I could show you exactly how you do that. But typically, if I look at my functional exchange here in the semantic browser, I'm going to see that there are some exchange items, which is the audio video stream header. I could actually navigate to that. Let's do it that way and open the diagram. So this is, the data diagram that is modeling that is representing the data that is flowing on our on our functional exchange. Okay. And if I look at my behavior component exchange, I can see here that there are two allocated functional exchange, the packetized audio video stream and the stream header, which are exactly those two functional exchange there. Yeah, by the way, the dashed lines are actually representing the allocation of the functional ports to the component ports. So there can be quite a lot of manual things to do, but again, this is not something that you have to do manually. Once you have allocated functional exchange to a component exchange, there is a modeling accelerator there that is going to propagate the port realization from the realized component exchange. So that is all done automatically for you. All right, let's go back to the slides now. Okay, one thing that I haven't showed you today, because we have a limiting time, and Capella is a very rich environment, and there are many other things that I could have showed you, but one important functionality of Capella is what we call the rec and the RPLs. You may have not noticed here, but when we do modeling in Capella, we model directly with instances. We don't have this object orientation paradigm that is coming from the software industry that you will find in SysML models, like it's the case in SysML v2 with usages and definitions. But that was the case in SysML v1 as well, where before being able to define a usage, you have to define the definition. Where in Capella, it's not the case. We believe that when system engineers want to model an aircraft, they should be able to just model an aircraft and a passenger. Is a passenger, you just create an element passenger. Nevertheless, this concept of usage and definition is really useful when you want to do some reuse. And typically, if you are modeling a car and you have 4 wheels, well, you may want to model what a wheel is and then reuse what's common between those 4 wheels by instantiating those 4 wheels, reusing this generic wheel concept. And so there is a way to do that in Capella that is called record and replicas. The way it works basically is that in Capella, you can select any set of model elements, can be a couple of model elements, can be thousands of model elements, and you can make them become a record. Once it has become a record, what I mean is that you right click and you say, okay, now that's a record. That's what it is. Now that it's in a record, you can then replicate it anywhere in your model. So it's kind of like a copy and paste, but it's a little bit more intelligent than that because you are able to manage the consistency and the synchronization between the records and the replicates. This mechanism in Capella is heavily used by our users. And what they are doing is they are generally building libraries of records, which are elements that are reused across the company. And they are building architectures by taking those records and creating those replicates within the same projects or within different projects. So very important feature and very heavily used feature in Capella. And I'm sorry, I hit the wrong key. Let's go back there. Right, so I spent some time to explain Arcadia and to explain Capella as well. But Capella being an open source tool, it's also an ecosystem. And the way we have developed the Capella tool is as a platform. that is very extensible so that users can extend and customize the tool based on their need. So there is a set of extensions and add-ons to Capella that are very commonly used by the users of Capella to address a certain number of aspects and features that are needed by a system architecture tool. The first need is to be able to collaborate on the model within your team. And for that, there are different ways to do it. First of all, there is a very strong support with Git integration within Capella. So most of our users, they would generally use Git to work with Capella. Now, beyond Git, there are a couple of other add-ons that are used for collaboration with the tool. And these add-ons are commercialized by us, Obeo. The first add-on is Team for Capella. And what Team for Capella does, it basically enables you to have a real-time collaboration on Capella models. It's the same, very similar user experience as if you were to collaborate with Google Docs, where you can be several people opening the same documents and getting live updates of changes in your documents. But with a tool, a modeling tool like Capella, I've got a very short video for that to give you a sense of what it does. I'm going to go there. So typically, you've got two users, and one of the users is starting to change, let's say, a name of a physical function. And as soon as it has changed the name, the user automatically takes a lock. So that's a green lock that we've got here. And the other users are automatically notified that this element has a red lock, so it cannot be modified anymore, and all its properties are locked. Because the user has also changed some layout of the function, it has taken the lock of the diagram, but the other users can still work on other functions where no lock is taken. And now you see the lock is taken here, but Bob cannot modify this one. And the lock are automatically released when the user saves the changes, and the changes are automatically propagated to all the other users so that you get updates and an up-to-date model in real time within your team. All right, so this is what Team for Capella does in a few words. We have also Cloud for Capella, and this is, we have some users that don't want to install and to have their users install Capella in their machines. So in that case, they would use our software as a service offer that we have, Cloud for Capella. And what we do is that we install Capella in a cloud environment, and the users are able to use Capella directly within their browser without having to install anything. So that's another way to collaborate very easily with Capella. And that can be used in conjunction with Team for Capella, obviously. Right, the second set of needs that you can fulfill with some of the Capella add-ons is to exchange Capella models with others. And for that, there are different ways to do it. It's very common that, users just exchange models because, Capella is free and open source, so you just download it, you get a model file, and you can open it. So very easy way to exchange a Capella model. Now, there is also the rec RPL mechanism that is part of Capella that I mentioned earlier. Very efficient way as well to share not only models, but models of reusable elements. The system to subsystem transition is also a very common way to exchange models with Capella. It's an open source add-on. And what it does is, as I explained, when you are at the physical architecture at the system level, for example, you can select a few components, say, okay, these components are going to be developed by a separate subsystem team. Let's initialize a Capella model. where the system analysis is already initialized for you based on what was defined at the system level. So very commonly used add-on as well to manage the different engineering levels within complex projects and complex systems. And finally, the filtering add-on is another add-on that is very commonly used in the Capella ecosystem. It's open source as well. And what it enables you is to extract some parts of your model based on some specific rules. So typically, you want to collaborate with a co-contractor, but you don't want him to have access to all your model and all your data. Well, you're going to be able to write some filtering rules in the filtering add-on, and the filtering add-on is going to be able to generate a coherent Capella model that you can then hand over to your co-contractor so that he can work on his parts. Right. Third type of need is communication. You want to be able to communicate on the models that are available in Capella. There are several add-ons to do that. M2Doc is an open source add-on which enables you to generate Word documents out of your model automatically. The XHTML documentation generation add-on is another one. It doesn't generate a Word document, it generates an HTML website. It's open source as well. Python for Capella is a very commonly used add-on across the Capella users. And what it enables you to do is to script your Capella environment and your Capella models. And typically, a typical use case is, oh, I want to generate a matrix, dependency matrix out of my model. Well, you can write a bunch of Python scripts, very quick Python scripts, and you're going to be able to generate this data out of your model and to provide it to your stakeholders. Maple MBSE has a commercial add-on that have a live synchronization between Excel spreadsheets and Capella. And finally, we have another commercial add-on that we have at Obeo called Publication for Capella. I will talk a little bit about it later. But one characteristic of Publication for Capella is that you are able to publish your Capella model on a web server. And those models, they become accessible through a web interface. So you don't have to install anything and to install Capella. Just with the web browser, you're going to be able to navigate, search in your Capella models. And this is an authenticated website, so you can control who's going to access your data, basically. Yeah. Third need in terms of collaboration around Capella is to integrate with other engineering repositories. There are a few solutions for that. Actually, this slide is not complete. If you want a more complete list of the Capella add-ons, you can go to the Capella website. If I manage to get back my browser, and if you click on the Workbench menu, you're going to see add-ons there. And you have a list of a lot of the open source add-ons and the commercial add-ons. We try to have a complete list. It depends whether organizations are informing us about the existence of these add-ons, but generally we have a pretty good exhaustive list of what these add-ons are. Right. So I want to talk a little bit about Publication for Capella beyond publishing your model into a website that makes it accessible to others. What Publication for Capella does, it manages the traceability between application lifecycle management tools and Capella. So I have a list of tools that we support right now, like Polarion, JAMA, Codebeamer, Doors, and IBM ILM, Jira and Confluence as well, and other OSLC tools. And just a very short video of what I mean by managing the integration is how, so you've got Doors here, and how are you going to create a traceability link between a requirement and a Capella model element? Well, just by drag and dropping requirements from Doors next and dropping it on a Capella diagram, you can select which type of link you create. It's all configurable. So, very easy way to create this traceability. And you can then publish those models in the publication for Capella server. And once those models are published, those links, they actually become available directly from the requirement tool. So doors next here. And you can actually also create those links directly from Doors or Polarion or JAMA if you want. But yeah, once you have published your model, those links now become available and you can navigate them from the requirements to the publication or have a preview of the Capella element that it's linked to. All right. So that is publication for Capella. A few words on System Loading Workbench. So System Loading Workbench is an integration between Capella and Siemens Teamcenter. This is an integration that we have developed and we are maintaining and evolving for Siemens. And this product is actually commercialized by Siemens. And there are very nice integration between Capella and Siemens Teamcenter if you are using this PLM. What I wanted to say about these add-ons is that there are a lot of commercial add-ons, and we are doing a few of them, but like ANSYS has an add-on, MapleSoft, I mentioned it, Pure System, the reuse company, Dassault System has an add-on as well, ANSYS another one, that's System Rolling Workbench. So we are, there are a bunch of companies out there that are developing those add-ons as well. And finally, there is obviously the need to collaborate with specialty engineering. So there are different ways and different add-ons to do that. Dark is an open source add-on for modeling the cybersecurity aspects of your systems. Attica for Capella is a commercial add-on from Anzen, and it's very useful in terms of safety, especially for the aeronautics and space safety and defense. ANSYS has an integration between Capella and Model Center, which enables you to link your Capella model with a lot of simulation tools. There is an ANSYS SCADE connector as well. I'm just mentioning in this slide that we are in the process of also open sourcing a new Capella add-on that is a bridge from Capella to MATLAB Simulink that has been developed by Thales. This should be available in the next couple of months. All right, so I'm heading toward the end of this presentation and demo of Capella. What I want to say is that Capella is a very largely used and deployed tool out there. We have more than 1,500 organizations that are using Capella worldwide. There are a lot of case studies that are available directly on the Capella website. We have also on the Capella website some of the logos of the organization that have accepted to share their logo about the fact that they are using Capella. I've got a bunch of use case here. I'm not going to go I'm not going to go in detail about those use cases. Sorry about that. Wrong key again, but obviously Thales has multiple use cases. The European Space Agency is using Capella quite extensively for the Galileo system, which is a European GPS system. Rolls-Royce has been developing some of their new engines with Capella with success. Naval Group for the Navy in France as well is one of the use cases that we have. Ariane Group with the space launcher Ariane. They just did their first commercial launch with the Amazon satellites last week, I believe, with the Ariane 6. So the new heavy launcher from Ariane. And we do a lot of events around Capella. We have regular Capella webinars. We have the annual Capella online conference. All these events are free. We record them and we put them on the Capella YouTube channel. So if you want to learn more about what organizations worldwide are doing with Capella, feel free to visit the channels. We have more than 180 recordings of case studies and how-tos on Capella. And there is an excellent learning page on the Capella website. I can show you this one. All right. If you go to community training materials, Um, you've got courses. This one is made by Tony Comar from Siemens. You've got 41 videos on YouTube. Excellent tutorial from the University of Singapore on Technology and Design there. Some model examples and so on. All right, let's go back there. And finally, I just want to say that we are also developing a new open source project called CSON, where we are implementing the graphical syntax for SysMLv2. So it's basically a web-based modeling environment, graphical modeling environment. And it's fully open source and already available. I will be presenting that in this tutorial series on the 20th of May. And with that, I hope this presentation was useful to you, and I'm open to your questions. Let's look at the chat. I'm not sure there was any questions so far. Oh, yeah, missed that.
Yeah, hello, Stefan. Thank you for your presentation. Very insightful, very informative. So yeah, let's open up the floor for any questions that the audience may have.
So I see a couple of questions to start with, Jeffrey, on the chat. So Katie,
Yeah, I don't. Oh, okay. I see two questions. What is it? Two
yeah.
questions here.
So
Okay.
Katie asks, do you have an estimate about the size of user base of Capella? How many individual users, how many organizations, and how many projects? So I partially, answer these questions in one of my slides here. So we have more than 1,500 organizations that are using Capella worldwide. We believe it's one of the top 3 most used system modeling tool. It's not always easy, to find those numbers, and also because Capella is an open source tool, so we are discovering organizations that use it every day without us knowing it before that. In terms of number of users, very difficult to estimate. This is tens of thousands of users. I would say so. I would say though that Capella is less used in the United States because the DoD is kind of mandating SysML and Cameo. This may change with SysMLv2, and Capella has a very strong capability to map with SysMLv2. It's actually much easier to map Arcadia to SysMLv2 than SysMLv1. We have been involved in developing SysMLv2 and brought some of the ideas of Capella and Arcadia to it. Yeah, in terms of number of projects, I mean, we know that Thales has done more than 500 projects with it. Yeah, this is not something we are counting, but we have very large organizations out there that have been using Capella for more than 10 years, and they have done, dozens and hundreds of projects. So, difficult to estimate. What I'm going to say as well is that Capella is used in all domains where system engineering is used. We have a lot of users in the automotive, in the railways, lot of usage in the railway, mostly space, aeronautics, defense is our number one sectors. Healthcare, we have quite a nice adoption in healthcare, especially in the US. Yeah, energy as well. A lot of usage in energy, whether it's battery oriented or nuclear, quite a lot of usage in the nuclear industry. Yeah. Yeah, second
Got another
question is,
question there. Yep. Mhm.
yeah, is there a user forum for posting questions? Yes, that's a great question. I should have put that. So um, you're gonna be finding that in the help section in the community. You've got a link to the forum. The forum is forum.mbse-capella.org. So, it's the same URL as a website, except you put forum in top of it. And here you got a forum, and there is a pretty nice activity in the forum. There are several messages that are posted and answered every day, so you can you are welcome to post any questions you may have here. Next question, for reusability, does it manage the possibility of name conflicts between the model being developed with the reused model being integrated to it? Otherwise, one has to keep track of names already used. Right. So that's a great question. There are two ways we manage that. The first way is when you create a replica, when you create a record, so let's say the mother element that you're going to then paste into replicas, when you create that, there is a window that is going to be displayed, and you can bring in some variability in the record that you create. So let's do that, for example, create a rec. So this is the window that helps you to create a record. And here you can select any element and include some variability in the naming. And typically you can say that this synchronized audio video function is going to be named differently, like with a number 1, 2, 3, when you create the replica, or you can indicate that the tool should not try to synchronize the name and let the user change the name if they want to change the name. So that's one, technical way where we manage the variability of the name of the elements when you create those replicas, so that you don't have conflict of names. And then beyond that, I haven't mentioned it, but there is an extensive set of validation rules that comes with Capella, and we have rules that are going to help you find if you have duplicate names in your models as well. Can I generate N2 charts from the function diagrams? What about data dictionaries? So there are a certain number of matrices that you can create directly within Capella. Let me have a look there. So here you can create a traceability matrix that indicate the traceability between the layers. You can create a physical component, logical component matrix. You can create a physical component, so component function matrix. So that's, these are some matrices that are built in within the tool. If you don't find the matrix that you are looking for, there are a couple of things you can look at. In the add-ons, and I think that this one is going to be in the labs for Capella add-ons. I'm not sure I'm going to be able to find it quickly, but we have also a repository called labs for Capella, where you're going to find some add-ons which may not be completely industrialized, but there is a DSM for Capella add-on, if I'm not wrong. And this add-on is dedicated to creating some N2 matrices for functions, but beyond creating those matrices, it's also going to help you to decouple functions and to minimize the dependencies between functions. That's the role of this add-on. And there is a webinar that explains and presents these add-ons on the Capella YouTube channel. What about data dictionaries? I'm not sure what you mean by that. So if you can give you a little bit more information, maybe I can answer this question, but probably we don't do anything about it because I don't know about it. And then can I compare different diagrams between old diagrams and the new ones so that one visually see all the changes that were done? And the answer is no. To my knowledge, there is no a graphical deep merge between Capella diagrams. And one of the reasons for that is because in a lot of operational and professional environments, users use Team for Capella. And with Team for Capella, where you get automatic locks on elements and diagrams and automatic updates, uh, the bottom line is that we are using pessimistic locking so that you don't have to manage any merge between elements and diagrams. But it would be nice to have capability to do difference on diagrams. I agree. We did some work on that on the past, but that has not been industrialized in Capella, unfortunately. All right, any other questions? Feel free to unmute yourself as well, I guess, to ask a question. I don't know if it's a possibility, but yeah.
Yeah, folks are able to unmute and ask questions. I think another
Yeah,
one here. Did you ask, oh, did you already answer the diagram, the differences between diagram?
yeah. I was just
Okay.
answering that one.
Okay.
I mean, in any case, feel free to reach out to me. I'm always happy to help. I'm pretty active on LinkedIn as well. So if you're going to be finding me on LinkedIn and you can drop me a message there as well. And you can obviously go on the Capella forum and ask questions as well.
All right. Once again, Stefan, thank you for your your presentation on Capella. Like I said, it's very informative, um, and I learned a lot. I was familiar with Capella for many years, but I've never seen a demo such as this one about the product. So, thank you for doing this demonstration for us today. Um,
Excellent.
yeah. So this closes out our MBSE tools demo for tonight. Our next demo will be in March, late March. I don't have the exact dates, but you'll see an advertisement on the WMA website. We'll have Dassault Systems come in on site. Actually, it's this one is going to be a little bit different. It's going to be hybrid. It's going to be on site at George Mason University and online. They're going to be sharing details about their product, Cameo, and Teamwork Cloud. So more information on that coming in the next couple of weeks. So with that, I will close it out. And thanks again, Stefan. And actually, Obeo will be back sometime in the near future to talk about their SysML v2 tool called Syslon. So we look forward to that presentation and demo in a
Yes,
couple months.
excellent. Thank you
Mhm.
very much for inviting
Yeah.
me. That was a no, great to be able to present Capella to this crowd.
Yeah. Well, thanks. Appreciate it. All right. Good night, everyone.
Bye.
Bye.
Thank you.
Hey Jeff, you're still recording.
Yep, I'm gonna pause right now or stop it.